the three types: object, object, and object. This one is going to be weird. So you could think that if you have a variable that you annotate with a TypeScript object type, that would restrict the variable from accepting a primitive, a non-object value, just like this one, var n equals, for just trying to assign a number. And it's not necessarily the case. So let's take a look at our three variables. We've got O1, O2, O3. One is implicitly inferring the type of an empty object. The other one is explicitly of the object constructor from JavaScript, and the last one is the same as the first one, is just explicitly annotated. So what we would expect that would fail, and it certainly does fail, is that when we expect a number and we pass an object, this would fail, since there is no guarantee that an empty object could have the same functionalities as just a number, which is obvious, intuitive, and thankfully it works as expected. Though we could expect that the other way around, this is also going to fail, and as we can see, it doesn't. So what does that mean? When we try to assign something into an object, it basically needs to have the same functionalities as an object. So let's see what functionalities does an object have. So besides the constructor, it has the 6 methods: has on property, is prototype of, etc. So these are the only 6 methods that are available on all JavaScript runtime objects. So for instance, we could ask for the value of a thing, whether it's O1, O2, or O3. So the thing is, TypeScript is telling us that if we pass a number, we could actually invoke the value of and other methods available here on this object. So let's see if this is going to be the case. So let's take 5, and what we can see here is that actually, yeah, we can run, for instance, the value of, which is going to be, well, certainly the value which is 5. Let me just run it in the right way. Or if we try to see whether it has own property, and let's just put what is the property name that we're going to ask. So if we pass a primitive value and we try to treat it as if it was an object, as we can see, JavaScript is going to automatically box it up to become an object. So what is going on under the hood is that the primitive is casted just to an object, and the object has all the methods. So even though this is a primitive and it has no properties, no methods whatsoever, then it's just going to be boxed. Same with strings, same with booleans, same with symbols, begins, and so on and so forth, except for null and undefined. If we try to treat those as if they were objects, now this is going to fail because, well, basically automatic boxing, auto-boxing doesn't work for both null and undefined. So if we try to assign null over here, now this is going to fail. If we try to assign undefined, this is still going to fail. Undefined is not assignable to type object and to type empty curly braces. So let's take a look at this one as well. So null doesn't pass, undefined also doesn't pass. So if we try to assign a boolean, it's going to work. If we try to assign a bigint, it's going to work. If we also try to assign a symbol, it's still going to work. Why? Because they all have their corresponding object types, and null and undefined don't have it. So again, going back to the main question, if we want to filter out the primitive values out from an object, we have to reach out to build into TypeScript the lowercase object type. And you can think of it as if it was something artificial in TypeScript, because there is no corresponding thing, no corresponding function, constructor, prototype, etc. in JavaScript runtime. So this is the constructor of all JavaScript objects. It does have its corresponding prototype. However, this is purely a TypeScript thing, which is going to just disallow all variables which are just annotated with the type. It's going to disallow to accept, for instance, a primitive number, but also all other primitives. So bear in mind that whenever you have the uppercase O, uppercase object, or the empty curly braces, what you filter out is only null and undefined. And you could think that the uppercase object and the empty object is actually the same thing. So to make things worse, this is not necessarily the case. So let's see one more example. So let's create let x1 and x2, which are going to be of the different types. So let's see a tiny difference between the two. So what we care is that we would have a toString method, which is going to return what the thing is. So here, the funny thing is that this is toString, and what we're returning here is basically a number. And here we're going to repeat the very same thing. And here, as we can see, we do get an error since, well, when we return a toString value, the result of calling toString, well, this should be a string, and this is certainly not a number. So what we can see is that in this uppercase O, the implementation of these 6 built-in methods, the 6 ones that we have seen over here, it's going to be checked for type safety. And with the empty object, this declaration doesn't include all of them, and this is the reason that we didn't get auto-completion over here. We just don't know what are possible values over here. So this is the only difference between the uppercase object and the empty object literal.